It shouldn't be. I hope not. Well, let's take a peek and see how it comes out. There's always a chance that this time in the morning I screwed the problem up and it came out to be a decimal. Who knows? But let's see what happens here. Actually, it looks like I might have screwed up, but we'll see. I see one number that's different than what I intended it to be already. So let's see what we get in here. We've got 5, then what do we do with the m? It's a 6. There we go. M equals 6. So 5m becomes 5 times 6 minus 2 times p is going to be 4. So it'll be 4 squared minus 4t becomes 4 times 5 over 6. F becomes 2 and y becomes 2. So 6 times 2 plus 2. So now we're going to start on the top. In the parentheses, we have to do the 4 squared is 16. Then I have to do 4 times 5 is 20. 16 minus 20 is negative 4. So now we have 5 times 6 is 30 minus 2 times negative 4 is negative 8. So it ends up being 38 on top. On bottom, what do we have to do? Bless you. 6 times 2 is 12, plus 2 is 14. So it's 38 over 14. How many of you got to that point? Nobody? 1, 2? Okay. So then 38 divided by 14 is 2.714285714.3 approximately. We divide it out as a decimal. How many of you got that? You got it? Anybody else? 2? That's not the greatest batting average I've had. Is there anybody that's really stumped as to how to do these? Just getting the numbers plugged in? Is it plugging in the numbers or is it the order of operations?
Well, where you got negative, I ended up with, I don't know how I got 28, but yeah, that's where's the beginning of mine.
Okay. Well, that's the problem with any of these order of operation type problems. One screw up, and you know there's 20 steps in some of them, and one screw up, and it's all done after that. Have you done okay with similar problems in the past, or just this one just didn't work?
No, just this one, yeah.
Throwing that negative in there was kind of cruel.
Yeah.
At this point in the morning, I may not be a very nice guy. Okay, so remember, by the way, that tomorrow is our first unit test, so be ready for that. I want to look at today as a topic that, actually a couple of topics kind of go together, but one of the more powerful tools in math that really doesn't get taught and people aren't taught how to use, because most of the things you could use it for, we get kind of trained to do it in our head without thinking about it. What we're going to talk about today is factors. And what factors are just numbers that divide into other numbers. For example, if I asked you for the factors of 18. Well, numbers that will divide into 18 without a remainder. 18 can be divided by 2. It can be divided by 3, because 18 divided by 3 would be 6. Can it be divided by 4? No, 18 divided by 4 would be 4.5 or 4.5. That's not a factor. It has to be divided without a remainder or without a decimal or a fraction. Is 18 divisible by 5? No, so 5 is not a factor. 6? Yes, so 6 is a factor. 7? No. 8? No. 9? Yes. Now we stop there because 9 is half of 18, so there's nothing bigger than 9 that's going to go into 18 without producing a decimal or a fraction at least. Now, in some cases, they would list 1 and 18 as factors. But we don't include those just because they're not really factors. We don't dividing by 1 we don't consider to be a factor of a number for most purposes. So 2, 3, 6, and 9 are the factors of 18. So the first thing I want to do is I want to take a little bit of a side trip here and talk about finding factors of a number and some shortcuts we can use to find factors of a number. And what I'm going to talk about is divisibility rules. Obviously, if a number is a factor of another number, it's divisible. You know, when we said that 6 is a factor of 18, that's telling us that 18 is divisible by 6. What does it necessarily mean to be divisible? Well, it's just like we were talking about before. 18 is divisible by 6 means 18 can be divided by 6, and it'll produce a whole number result. No fraction, no decimal. So how do we tell if a number is divisible by another number? Well, let's say that we want to know if a number is divisible by 2. How can we tell? Okay, but are there any tricks we can use to figure out if a number is divisible by 2? It will go in there equally without a decimal or a fraction or a remainder. There you go. Ends in. The last digit is an even number. In other words, it ends in a 0, 2, 4, 6, or 8. So if I throw out an example, 53,297, is that divisible by 2? No, the 7 is not even. 284,934. Is that divisible by 2? Yes, because 4 is even. How do you tell if something's divisible by 3?
And then an odd number.
Nope, 6 is divisible by 3, and it's not an odd number. But to tell if something's divisible by 3, it's a little bit more complicated. Look at the sum of the digits. What's that mean? Well, let's take 5,286. Now this ends in a 6. And some people, well, the last digit is divisible by 3. Nope, that's nothing to do with it. What we do is we get the sum of the digits. What's 5 plus 2? 7 plus 8? 15 plus 6 is 21. Is 21 divisible by 3?
Yep.
Yes, so this whole number is divisible by 3. Do another example. So 9,259,347. Let's see if that is divisible by 3. What is 9 plus 2? 11 plus 5? 16 plus 9? 25 plus 3? 28 plus 4? 32 plus 7 is 39. Now, if 39 is divisible by 3, the whole number is divisible by 3. But if we're looking at 39 and we're not sure, we can actually do it again. What's 3 plus 9? 12. Is 12 divisible by 3? Yep, so then 39 is divisible by 3, and therefore 9,259 or 9,259,347 is also divisible by 3. Kind of an interesting little rule.
That only works if you're trying to
Divide by 3.
divide by an odd number, or just by 3.
Just by 3. It will also work for 9, and I'll show you that in a little bit. How to tell if something's divisible by 4? Well, the last digit is going to be even again, but that's not enough. Normally for 4, I don't even worry about whether numbers are divisible by 4 because I just divide by 2 twice. But if we really want to figure out if something's divisible by 4, we look at the last 2 digits. And if the last 2 digits are divisible by 4, then the whole number is divisible by 4. So if we have 74,289,392. If we're looking to divide by 4, out of that whole number, all we care about is the last 2 digits. Is 92 divisible by 4? Yeah, it is. So since 92 is divisible by 4, this whole number is divisible by 4. Now that works fine if you know your 4s up to 100. If you don't, well then it's not so simple. But you do know, looking at that number right away, is it divisible by 2? Yes, it is, because that last digit's even, so you can divide by 2. So we don't really care if it's divisible by 4, because we can just divide by 2 twice, and it works out. I'm not going to say we don't care. I mean, there are cases where it'd be easier to divide by 4. How about 5? Tell if something's divisible by 5. Ends in 5 or 0. So just like with the 4s, we don't care about the whole number. All we care about in this case is the last digit, 5, which tells us that this is or isn't divisible by 5. Is divisible by 5. 6. Well, once again, I don't care a whole lot about 6 because I can divide by 2 and then divide by 3, and it would be divisible by 6. In fact, the rule for 6 is it can be divided by both 2 and 3. So if it ends in an even digit and you add up the numbers and the digits are divisible by 3, then it's divisible by 6. So looking at this, is it divisible by 6? How many of you are adding up the digits right now? A few of you? Do we need to?
No.
So this last digit is 9, which tells us it's not divisible by 2. Therefore, it can't be divisible by 6. How about this one?
Yes.
Is it divisible by 2?
Yes.
Yes, it is. That's 2 plus 7. 9 plus 4. 13 plus 9. 22 plus 8 is 30. Is 30 divisible by 3?
Yep.
Yep, so it's divisible by 3. So it's divisible by both 2 and 3, so it is divisible by 6. Now again, to me that rule is complex and it's complicated enough that I'd rather just divide by 2 and then by 3 and get it over with and not have to worry about figuring out if it's divisible by 6. 7. Anybody tell me how to tell if a number is divisible by 7? Other than just knowing your football scores? 7, 14, 21. If you're a Viking fan, that's as high as you ever know how to count. Sorry. Actually, I should be careful. If you're a Viking fan, you know how to count 3, 6, 9.
Vikings can count a lot more than that.
Anyway, anybody know the rule for telling if a number is divisible by 7? Okay. Neither do I. I'll put this out there. If by the end of the semester you can figure out a rule, a method that works every time for figuring out if a number is divisible by 7, write it up and give it to me or show it to me, and I'll give you extra credit. I will give you an A in the class. You'll be done. I will publish it, get rich, and retire. Work out well for both of us. Okay, there is no rule for 7. They've been searching for hundreds of years and have not found one for 7s. For 8, 8, kind of like 4s and 6s to me, I can just divide by 2 3 times. So I personally don't really care if I can divide, of being able to look and see if I can divide by 8. Partially because the rule for dividing by 8 is extremely difficult. For a 4, we looked at the last 2 digits of the number, and those last 2 digits had to produce a number divisible by 4. For 8, we have to look at the last 3 digits. If the last 3 digits make a number that's divisible by 8, the whole thing is divisible by 8. So let's say we have 47,136. What we're looking at here is the last 3 digits. Is 136 divisible by 8? It is, but you wouldn't necessarily know that off the top of your head, would you?
No.
So this is divisible by 8. But how many people have their 8s memorized up to 999? I really don't. So it's just not feasible. It's not a useful rule in most cases. If you're desperate, I guess it's okay. If you don't have a calculator, I guess it's not so bad to know it. That way you only have to divide the last 3 digits by hand instead of the whole number. But still, not a terribly useful one. The rule for 9 is the same as 3's. It's with the sum of the digits again. Only this time, instead of being divisible by 3, the sum of the digits has to be divisible by 9. So let's take 47,313. Let's see if that's divisible by 9. Well, what's 4 plus 7? 11 plus 3?
14.
14 plus 1?
15.
15 plus another 3? 18. Is 18 divisible by 9?
Yep.
Yes, so 47,313 is also divisible by 9. So that one's not so bad. I mean, I could say the same thing about 9 as I have about 4, 6, and 8. That I could just divide by 3 twice if I wanted to, which is fine. But that one's at least not a bad rule. How do I tell if something's divisible by 10? Ends in 0. That one's an easy one. Now, as I keep going up from here, there are a lot of other numbers that have divisibility rules. There are several that they haven't bothered with because of one simple fact. There's 2 types of numbers. There are prime numbers and there are composite numbers. You might have heard the word composite quite a bit right now in the last several months or a couple of years, because there's a plant up in Superior that's doing a lot of work with composite materials. But composite materials are materials that are not a pure type. You know, you have metals, you have ceramics, you have polymers, which are the plastics. Composites are a mixture of 2 or more of those. You might have ceramic and metal mixed together. It's called ceramet. If you're into machining, it's very common. A lot of your tools and your inserts are made of ceramet. It's an extremely hard material. In the military, the helmets they use are made of ceramet. And actually, when I was in college, one of the professors I had in one of my engineering classes was on the research team that developed the ceramet material for those helmets. An extremely hard composite material. They mix it together and it has properties of both. So a composite is made up of other things, smaller ingredients. 18 is a composite number because it was made up of smaller numbers. I could break it up into 3 times 6 or 2 times 9 or whatever. That's composite. Prime numbers are numbers that have no factors. Now again, depending on how you define factors, because some books define 1 and the number itself to be factors. Let's put in set for 1 and itself. So like 11 is a prime number because there's no number other than 11 and 1 that can divide into 11. How about 27, prime or composite? Is there any number that can divide into 27? 9 or 3, you got it. That is composite. 51, prime or composite? This is composite. Divisible by 17 and 3. 57. I'll give you a hint. What's 5 plus 7? 12. So that actually can be divided by 3. That's composite. 61 is prime. So you can see here, if I wanted to see if something was divisible by 27, being a composite number, I really don't need a divisibility rule. Because 27 is divisible, can be split down into 3 times 9. Actually, split into 3 times 3 times 3. So I don't care about finding out if a number is divisible by 27. I can just divide by 9 and then divide by 3. Well, I can divide by 3 over and over again. Same for like 12. 12, of course, is a composite number. I don't need a rule for dividing by 12 because I can just divide by 3 and 4, or 3 and then 2 and 2 to divide out 12. So I don't care about divisibility by 12. So that's why after 10, I said only certain numbers have divisibility rules. Only the prime numbers have divisibility rules. 12 doesn't have one because it doesn't need one. 11 has a divisibility rule. 13 has one. 17, I think, is just like 7. It doesn't have one. The problem is as we get larger, the divisibility rules get more and more complicated. So we're only going to really worry up to 10. But let's say that after 11, let's look at what happens there. How do we tell if a number is divisible by 11? Well, you don't have to write this down because I'm never going to force you to do this, but it's kind of a complex rule. Let's take 724,520, what do we have there? 6. To find out if that is divisible by 11, we start with the first digit and we take every other digit. So 7, 4, and 2. What do those add up to? Well, 7 and 4 make 11 plus 2 is 13. Then we go back and take the remaining digits. 2, 5, and 6. Well, 2 plus 5 is 7 plus 6 is 13. So we get those two totals and we subtract them. Well, 13 minus 13 is 0. If that difference is either 0 or divisible by 11, this whole number is divisible by 11. So that's divisible by 11. So let's try. Oops, I don't know what the comma is for. Again, don't know what this comma is for, but it's okay. So let's look at this one. 9, 5, and 8, which add up to 22. Very good. Then we're going to take 2, 3, and 6, which add up to 11. What's the difference between 22 and 11?
11.
Is 11. Is that divisible by 11? You bet it is. So that whole number is divisible by 11. 13 is even uglier than that. So we're not, I showed you this one just to show you that there are rules out there, but like I said, they get more and more complicated as the numbers get bigger, and they're just not worth it. Trying to remember the rule is more difficult than just dividing out by the number. So for our purposes, the 1s through 10 are pretty useful because they're fairly simple. So back to our factoring. We've found prime numbers and composite numbers. This idea of a prime number, a number that has no smaller factors, like I said, no factors at all other than 1 in itself, is kind of useful. Because when we go to factor, let's say I'm asked to factor 36. Well, there's all sorts of different factor pairs I could come up with for 36. I could have 2 times 18, that's a factor pair for 36. 3 times 12, there's a pair of factors. 4 times 9 is a pair of factors. 6 times 6 would be a pair of factors. How do I know which one I want? Well, in most cases, none of them. But any one of them might be useful in different situations. So rather than leaving it ambiguous like that of, okay, factor this number, what we usually look at is something called prime factoring. Prime factoring means we break that number down into the absolute smallest pieces, as many of them as it takes, but the absolute smallest pieces that we can. For example, 36 gets split into 2 times 2 times 3 times 3. Well, how do I come up with that? First of all, 2 and 3 are both prime. There's no way to split them up into smaller numbers being multiplied together. Second, they do multiply up to 36. So the question is, is there a process that allows me to find those, or do I just have to know them or guess them, or what do I have to do? Well, some of you might remember good old factor trees. So from 36, all we need to do is find one number that will divide into 36. Can anybody give me one number that divides into 36?
6 times 6.
6, okay. So 6 goes into 36. If I divide 36 by 6, what's left over? 6. So that goes on the other branch of the tree. So this is saying 6 times 6 makes 36. Both of those can be split even further. 6 can be split into 2 times 3. Now, 2 is prime, so I'm going to circle it or put a box around it. Either one, doesn't matter. Telling myself that it's done. I don't need to do any more. How about 3? Is that prime? Yes, it is. Well, this other 6 is also 2 times 3. Now, when I go to put them into my factors up here, usually I put them in order from smallest to largest. That's why I did 2 times 2 times 3 times 3. Now, that's not the only way I could have prime factored 36. I could have looked at it and said, hey, that's 4 times 9. And then split the 4 into 2 times 2. And the 9 into 3 times 3. So most of these numbers have several different paths we can take in that factor tree to get to those prime factors. Let's say I ask you to prime factor 48. Give me a single number that goes into 48. 3? So 3 goes into 48. 48 divided by 3 would be 16. So now 3 is prime, so I'm going to circle it. I'm done with 3. Give me a single number that goes into 16. 4. 16 divided by 4 would be 4. So 4 times 4 is 16. Is 4 prime? No. So I keep going. 4 splits up into 2 times 2, which is prime. This 4 then will also be 2 times 2. Putting them in order from smallest to largest, 48 breaks down into 2 times 2 times 2 times 2 times 3. If you really wanted to take a shortcut, you could do this. 4 2's multiplied together is the same as 2 to the 4th power. You could write it as 2 to the 4th times 3. For our purposes, either one of these is just fine. I'm going to have you guys try to factor one here quick. I'm going to have you try to factor. Oh, let's see here. Try to factor 180. So what's one number that divides into 180? Well, we see that it ends in 0, which tells us 10 is an easy one to shoot for, right? You might have used 2 or 3 or 9 or 20. There's all sorts of numbers you could have used. Okay. So if we divide by 10, what's left over? 18. When I'm doing factoring, one of the first things I always look for is tens because they're easy. The number ends in 0, you know you can divide by 10. The second thing I usually look for then is 5s because if it doesn't end in a 0, maybe it ends in a 5. And then I usually jump down to 2s because the 2s are pretty simple because that last digit will be even. But then if I don't have 2s, then I try 3s and I go from there. If none of those work, then you got to worry about the odd numbers like 7 that doesn't have a rule or 11 or any of those and try to divide. So neither one of those is prime, so I have to keep going. 10 splits into 5 times 2. Both of those are prime. 18 can be just divided by 2, so 2 is prime, leaving me with 9. 18 divided by 2 is 9. 9 splits into 3 times 3. So 180 is 2 times 2 times 3 times 3 times 5. Any questions? Okay, well, you might be sitting there wondering, why do I care about factoring numbers? What is this good for? Well, there are a couple of tools out there that are very, very useful. Something called greatest common factor, usually abbreviated GCF. What the greatest common factor is it is the largest number that divides both numbers. So what we're looking at is a pair of numbers. Let's say we want to look for the greatest common factor of 60 and 80. Well, some of you might be able to look at that and know that both of them can be divided by what? 20. So 20 is going to be the greatest common factor there. But let's say we didn't look at those. When we looked at those, we didn't see that they're both divisible by 20. Or we saw that they're divisible by 20, but we're not sure if there's something larger that can divide into them. What we can do is we can look at this factoring. 60, if I did my factor tree, would be 2 times 2 times 3 times 5. Is everybody confident they can get those factors by doing the tree? Is there anybody that's not really sure and wants to see how wants me to do that one out? Okay. 80 then would be 2 times 2 times 2 times 2 times 5. The greatest common factor is a combination of all common factors. They both have a 2 in common. They both have another 2 in common. Is there anything else they have in common? A 5. So the common factors here are 2, 2, and 5. 2 times 2 is 4 times 5 is 20. 20 is the greatest common factor. It's a combination of all the common factors put together. So let's say I wanted to find the GCF of 42 and 66. Factor 42 quick. You factor 42, I'll factor 66. So it divides into 2 and 21 and 3 times 7. So 2 times 3 times 7 is 42. 66 I've already factored into 2 times 3 times 11. So what do they have in common? 2 and a 3. 2 times 3 is 6. 6 is the greatest common factor for 42 and 66. When we go to do fractions, greatest common factors are going to be what we're looking for to reduce our fractions. Algebraic numbers, greatest common factors, come into play quite a bit too, but we're not going to get that far into algebra in this class. There's another thing called a least common multiple. Least common multiple is probably even more important when it comes to dealing with fractions, usually referred to as an LCM. What a least common multiple is a combination of all factors. But it eliminates duplicates. So what that means is we're eliminating factors that are used, repeated in both numbers. For example, let's say I want to find the LCM of 12 and 18. Now, if I wanted to just find a common multiple, I'd just do 12 times 18. 12 times 18 is 216. That will be a common multiple, but it's kind of large. We'd rather work with something smaller. So if I factored 12, it is 2 times 2 times 3. 18 is 2 times 3 times 3. The easiest way to eliminate common factors is to use the powers. I'm going to write this as 2 to the second power times 3. This is 2 times 3 to the second power. And the way I do the least common multiple is I take all of the factors. There's 2's and there's 3's. Then I look at each of them and I take the highest power. What is the highest power that appears on a 2? 2. What's the highest power that appears on a 3? 2. So this would be 2 squared times 3 squared, or 2 times 2 times 3 times 3, otherwise known as 36, is my least common multiple. Let's say I want to find the LCM of 16 and 20. So 16 and 20, if I factor them, 16 is just 2 times 2 times 2 times 2. 20 is 2 times 2 times 5. So what I'm looking here is I have 2's and I have 5's that are factors. What's the highest power on the 2? This would be 2 to the 4th. This is going to be 2 squared times 5. Highest power on the 5 is just the 5, just 1, right? So 2 to the 4th, 2 times 2 times 2 times 2 times 5 is 80. So 80 is the least common multiple. Now for right now, we're not going to worry about greatest common factors and least common multiples. What we're going to worry about is that you can do the factor trees and come up with these prime factors. So for our last 6 minutes or so here, you guys can take a look in your book on page 26. Problems 1 through 63, the odds. Now again, I don't expect you to factor out 32 different problems here. Do a couple of the easier ones. If they're going really well and they're easy for you, skip ahead to the more difficult ones. But there's 32 of them there if you need the practice. Again, a reminder, tomorrow is our next class is our Unit 1 test, so be prepared for that. You may use your books and your notes and your calculators on that whole test. And I'm going to pass out some of your old quizzes here quick.